See how can we tackle this. So you will be given an array. So let's say array is of size is of 10 minus 5 minus 2 4 0 and 3. This is an array, and you are also given k value. So let's say k equal to 3. So you are allowed to jump from a given index to I plus k index. So that's what he is saying. So you have I plus 1 to I plus k. So for example, you are allowed to take a jump, for example, from this index. So I am at index 0. So from this index, you are allowed to take a jump from I plus 1 to I plus k. So min of I plus k or n minus 1, whichever it is. So you can take, you can, yeah, that's correct. So from this index, so you can simply, from this index, you can simply jump next I plus k jumps. So in this case, you are at 0th index, right? So you are at 0th index. So k equal to 3. So it means you can take 3 jumps. I can take jump to here, or I can take jump to here, or I can take to jump to here. So this is what he is trying to say. And let's say uh, I am at this index. Let's say I am at this index. So I can take to this. I can jump to this index, or this index, or this index. Or I am at this index, I can take to jump to this index, or this index, or this index. So if I am at this index, so I can simply take to jump to this index or this index. So what he is trying to say is, uh, we need to find out maximum score. How do you find out a maximum score? So you will be given an array and the k value. So you are allowed to take at most I plus k gems. It means from a next index onwards, you can move from in the range. Next index means, for example, you are at 0th index. The range is I plus 1 comma I plus k or n minus 1. So whichever it is. So this is the range. For example, I am at index 0. So I can start from range 1 to I plus k or n minus 1, whichever is minimum. So I is 0, so k equal 3 means from 0th index I can reach up to 3rd index. So this is what is trying to say. From 0th index I can reach up to 3rd index. So similarly, that's how you move on. We need to reach the last index, so that is n minus 1 index. So to reach the n minus 1 index, what is the maximum score you can gain? What is the score, which is the score is represented? So once you visited a current index, so that is the score. Whatever value you present, whatever value present in the current index, so that is the score you gain. let's say here let's say here, so this is my given input. So I am at index 0. As I am at index 0, so from index 0 I can visit any one of the 3 indexes. I can visit either this one or this one or this one. So I can take any one of the gem. Let's do what I'll do. From index 0, I can directly take I plus k. So it means I can directly reach to 3rd index. So I will reach here. From here, I can reach next index or any other next 3 indexes. But if you see, next 3 indexes is out of range. So that's what he's saying. Min of I plus k or n minus 1, so whichever it is. So I am at index 3. So 3 plus 3 means 6, or n minus 1 is 5. So you can reach up to 5th index. So from here I can directly visit here. I can reach here. So if you closely see, within 2 gems I reached n minus 1 index. So whichever, so as you reach n minus 1 index, so you are already reached the end goal, so that you can just consider the score on each index. So first I am at 0th index, which is 10. Then after I moved here, so here I got the score as 4. Then I moved here, which here I got the score as 3. So the total score is 17. So this is what is the expected output. Is the problem statement is clear, or Any confusion? Oh, no confusion, correct. So let's say, let's take one more input. So I have one more input as 1 minus 1 minus 2 4 minus 7 3 and k equal to. Okay, so now this index can reach here or can reach here, but if it is reaching here, it gets the maximum score as 0, because 1, you get 1 here, right? So once you reach here, you will get 1. Then from here you can reach till here, so that if you reach here, obviously you will add current value to this, so which is going to be, so these are the directions. Let's add all of the values. So plus 4 plus 3, so which is equal to 7. Yeah, it's perfect. So what, so this is one more input. So what is trying to say, from index 0 he reached here, so that then from here he reached here, from here he reached here. So this is the maximum path you could gain. So you visited all the indexes, you just take the sum of all the indexes values, which is 7. But if you take other direction, so let's say other direction is this one. Let's say other direction, this could be one more direction. So let's say you are visiting from index 0, you are reaching index 1, and from index 1, let's say I reach to index 2, and from index 2 I reach to index 3. Now if you sum up all the values, 1 minus 2 plus 4 plus 3, so which is 6. So if you go other directions, it is always going to be smallest value. So this is the max value, so we need to return the maximum score you can gain. So let's see how do you tackle this. So let me take the first input, or this one. So 1 minus 1 minus 2 4 minus 7 and 3. Okay, so this is at 0th index, this is first index, second index, third index, fourth index and fifth index. Okay, so at the end I must and should reach to n minus 1 index, that is for sure. So I must and should reach to the n minus 1 index. Let's take k equal to. So it means I am at fifth index. I am at fifth index. So I need to reach to the fifth index. So I can reach the fifth index from previous two indexes, right? Because k equal to. Yes or no, buddy? Yes or no? Please. Yes or no, buddy? Please.
Yes.
So either I equal 3 or I equal 4, because from previous two indexes. But let's say I am at index 3, so I can reach index 3 either with from previous two indexes. So I can reach from index 1 or index 2. Okay, so let's say I am at index 1, so that I can reach from index 0. So if you are at index 0, then so there is nothing you can do. So because index 0 you can directly reach, the cost to reach index 0 is 0. So means this is the base case. So when you are at index is 0, so you will just return 0. Now what is my point? So now from index 2 you can reach from index 1 or index 0, because k equal to. Similarly this one can be reached from index 2 or index 3. So let's move on. So now when you are at so when you are, let's say this one, right? So let's say this one. So index 0 you can reach from previous two indexes, so which is going to be minus 1 and minus 2. So when minus 1 and minus 2, so definitely you will return 0. Correct, nobody? You will definitely return 0, right? So because from index 0 you can move on to previous two indexes, but whenever you see negative value, so this will return 0. So let's see. Okay, so this will return definitely 0. Okay, fine. Okay, so now let's move on. Let's move on. So this will return 0, because index 1, to reach index 1 it is always be 0. Now Now if you see index, sorry, to reach index 0, it will always be 0 because previous ones are negative, so you can simply return 0. To reach index 1, I can reach from index 0 or minus 1. So means minus 2 means minus 1. So this will return 0. Index 0 means you are visiting index 0. So from index 0 you are reaching index 1. So that you can take the index 1 value, sorry, index 0 value, which is 1. So index 0 will be 1 and other one is 0, because we need a maximum count, right? So we need a maximum count so that I can simply take the maximum out of it, so which is going to be 1. Is this clear? Till now it is clear. So to reach index 1, right? So from index 0, if I want to reach index 1, right? If I want to reach index 1, so you can consider the weight of this one, so that index 0 value is 1. And of course other direction is negative, so that you can return 0. As we need a max score, right? So we need to find out a max score so that you can consider maximum out of it, so which is 1. Now closely understand. So this is returning 1. Okay, so 1 plus this is the maximum score you got, so which is 1 plus. So again, if you closely see, let me change the direction so things will be more smoother. Okay, so let me change the direction. Okay, so first of all I want to reach index 5, so it means you are visiting index 5. So first take the index 5 value, so which is 3 plus. So what is the max value you can attain, so that you just need to get. Similarly, I want to reach index 3, so means index 5 you can reach from index 3 or index 4. So if I reach index 4, from index 4 I can reach index 5. So sorry, from index 3 I can reach index 5. So index 3 having value plus 4. So 4 plus what is the max you can attain, so just get that. Similarly, you can reach index 5 from index 4 also. At index 4 I have minus 7 plus. So for remaining 2, what is the max value you can get, so just do that. Now let's move on. So index 3 can be reached from index 1 or index 2. So if I go to index 1, so this is my index 1, so which is minus 1. And to reach index 1, so what is the max value I could gain? So let's do that. Other direction definitely return 0, so it is minus 1. So here also minus 1 and minus 2. So this will return 0. So to reach index 0, so I just take the index 0 value. So 1 plus what is the max value I could get, which is 0. So let's move on. So to reach index 0, it is 0. So from index 0 I can reach index 1, and other direction giving 0. So this one return 1, this one return 0. So 1 comma 0, the max is 1. So it add plus 1 here, so that to reach index 1 the cost is 0. And let's move on to index 2 also. So index 2 means this is minus 2, right? So minus 2 plus to reach index 1, so you already calculated to reach index 1 the cost is 0, so which is already been calculated here, so that here the cost is 0. And for index 0, to reach index 0 the cost is 1, so that these two max is 1. So that if you closely see, in the left direction you got value 0, in the right direction you got value minus 1. So the max of these two values is 0, so that just take 0 here. It means index 5 you can reach from index 3. So if you reach from index 3, so you got max as 4. Similarly, let's move on to you can also reach from index 4. So index 4 can be reached from index 2 and index 3. To reach index 2, we already know the value, so which is minus 1. And to reach index 3, we already know the value, which is 4. So the max of these two is 4. So I'd consider 4. So minus 7 plus 4, which is going to be minus 3. So out of these two values, max is 4. So take 4. So the total value is 7. Is this clear, buddy? Or did I confuse you? So what is your job? So it's a pure recursive code. Of course, we are discussing in DQ, but I will tell you the way to solve this problem through DQ. But let's understand the recursive code. So but here if you closely see, we are solving same problem again and again, na buddy? Correct, na? So we are trying to solve same problem again and again. So it's time for us to hash it, right? So if I want you to write the recursive code. So this is how it should be, right? So this is how it should be. So let's move on. Okay, so yeah, what is the state of my recursive method? Can you please tell me? How is my recursive method structure should be? Can you please tell me? Let's say method name is solve. So one is we need index, right? Yes or nobody? We need index,
Yes,
and we need given input array also. And what else?
the current sum.
That's not required, right? Current sum we just return from here, keep on returning from here,
Correct. Yeah.
right? So I think this is needed. So let's move on. So what is our job? So we will optimize it. So this is my let's say solve with index and integer nums, and also we need k because we need to backtrack. That's what. So we are starting from top down, right? It's not bottom up. So we are doing top down. If you closely see, we are starting from 5 to 0. So let's move on. So what is our job? So one thing for sure, if okay, so one thing for sure, I will start, right? So integer start equal. I'm just trying to manipulate the same thing. Let's do how it can be. So because I'm doing backtrack, right? So it can be out of negative also. So that what I'll do, I'll start from 0 to whichever is maximum. So current index minus k. So whichever is maximum, and start is less than index. Correct na, buddy? And start plus plus. Correct na? Is this clear? Is this clear? So if you closely see, this is what we are doing, right? So yeah, perfect. So if you understood, that's good. Once we get this, then what is our job? So we need to find out. Yeah. So what is our job? So we need to find out. Uh, okay. So we need to find out max value in all the directions, right? So from here, if you go left, you need to find max. If you go left, you get one value. If you go right, you get one more value. So that out of all these, we need to find out max. In this case, k equals 2. That's why you got two branches, but k can be more than that. So what I can do, I will try to find out max equal integer dot min value somehow. Okay, so this is my integer dot min value. So what I will do, I'll try to solve it. Solve for this start. If I start from this index and nums and given k, done. So then what we should do, each time we are trying to consider current index value. So that's what we are doing, right? So if you closely see, current index plus okay, so each time we are trying to move on. This is my index. So I just started I minus k to here, then you went here, then you went here, then you went here. Okay, so when index is 0, you can blindly return that. Okay. Let me write it. So that map dot max of here, whether it is correct or whatever value I got, which is max, I will get somehow max. So once I get the max, I can simply return max plus the current index nums of index. Let me try this. So okay, base case is if index which is equal to 0, so you can simply return the value which is present in the index. Otherwise you can find out max somehow. Yeah. Is this clear, buddy? Is the logic is clear? If you closely see what are we doing, so we are taking whatever maximum you are trying to obtain through sub recursive calls. You take that max, you are adding to the current index, right? That's what we are doing. So this is my current index. Somehow I figure out what is the maximum value I could gain. Then I will just add max plus current index. That's it. So when the index is 0, so you don't go further. So it means you are reaching to the base case. You can simply return nums of index. So negative case we are handling here, so that there won't be any negative value. Let me solve it. So if it works, then I will explain better. Yeah, so this is nums and k. Yeah. Alright, do you understand, buddy? Do you understand the code, or is it confusing? So what are we doing? So actually I also don't know how to, I didn't write this code, so I just followed this recursive diagram and written the code. If you closely see, when you are at 0th index, it means you are reaching to the base case. So it means we are eliminating the negative value, so that I am reaching to the base case. So when you are reaching to the base case, you are simply returning the value. So it means when it is 0, it will return 1. And of course negative case will not execute, so that 1 comma max is min value, so that max becomes 1. So 1 plus nums of index, so it means from 1 you reach 0, right? So 1 minus 1, so it will return 0. Then in other end also, is this clear? Is the code is clear, Ajay, Maithili? Or shall I explain?
Actually, so when you were drawing, it was quite clear. But here, so let's say I'm starting with index is 5, right?
So
So I mean the
actually,
last index.
Mhm.
So then why are we going for every combination? So we should ideally check for indices so only with minus k, right?
It's a range, right? It is range, right? Yeah, so actually, if you closely see, uh, let's say I'm at index 5.
Okay, but start plus plus we are doing, right? Should it be start equal to
That's what
start
I'm
less?
saying. I started from last index, right?
Huh,
So k equal to 3.
yeah.
Okay, then I can reach this one from index 2, index 3, and index 4, right? Correct, na?
Yeah.
So now start is going to be what? I minus k, right? It means 2. So, and start less than I. It means 2 less than 5. Then start plus
Okay.
plus, right?
Okay.
So it means first
So it's not always three jumps they should do. It can be up till three.
up to 3, right? So it means
Okay.
you can always, so in the problem statement how it was given, if you are at index I, you can reach from I plus 1 to I plus k.
Okay. Okay.
So
Got it.
this is the range. So earlier if you closely see, we taken range as 2, right? That's why you can reach from either 3 or 2, 3 or 4, right?
Yeah.
So same concept. So here k equal 3. So k can be anything. So k can be 5 also.
Right. Yeah.
That's where we should. For example, when you are at 2, right? Then in this case, 2 minus 3 means you will get minus 1. So that what I'm saying is you start from 0, 0, 1. Is that clear? So if you closely see,
And that math.maxpert was written to handle the negative cases, right?
which one?
Math.max of
Yeah,
0,
that's what I'm
which
saying.
means
So if you see, if you are at index 2, right, index 2 can be reached from previous 3 indexes, means what will become -1, 0 and 1, right? So that we should not consider -1. That's why I just written start is max of 0 comma I minus k. So in this case 0 comma -1, so it will start from 0 less than I, so which is 2, so it means 0 1 it will solve. Is that clear, Maithili?
Yeah, clear.
Ajay, are you clear?
yes, Shunu.
Yeah, it's a pure recursive code. It's not something. Yeah, so through diagram only we should analyze and do it. The most confusing part is how this is working, right? One way is we are handling the base case. If you see, when the index is 0 means you are reaching, so that you are blindly returning that value. So once you get that value, then it's and from it means index 0 can be reached from index 1, right? So index 1, so index 1 you are trying to solve, because index 0 sum plus index 1 sum, so you are trying to solve. So once you reach index 1, if you closely see, this is what happening, right? So first we solved index 0. First we solved index 0. So once you solve index 0, it means you are solving index 1. So once you solve index 1, so you try to solve index 2. Index 2 can be solved with index 1 and index 0, so which are already been solved. So you can easily solve index 2. So once this is solved, you can solve index 3. And once this is been solved, index 4 also be solved, because which are already been solved here, so that then index 5 will be solved. So it was very linked code, but in this case, what is the time complexity here, please? What is the time complexity here? How many subtrees it is going to generate?
N into K.
Of course, but we are trying to solve the same problem again and again, right? We are not caching the result here.
Correct.
Yes. Yeah, if you solve same, that is different. So it should not be n into k also, even if you solve. So what is the time complexity here? Is it n into k, or yes, for n we are trying to solve previous case of problems, right? So n into k, yeah, that's correct. So the time complexity is n into k, right? Isn't it, Maithili? But we are trying to sub recursively calling, but still it end up with n into k. So what is the space complexity? First of all, is the time complexity is clear? I am thinking it is n into k. Is that clear? Yeah, so what is the space complexity here?
But Shrinu, if we take this scenario, we have 5 elements in 6 elements, and k is 12, right? But we are doing iterations more than 12 times, right? Because we are not caching anything.
No, if you closely see, for each, assume you have n elements, right? For each element, you are trying to traverse I minus k times, right? Yeah, if k is also n, then it is n square. That's what you are saying, right? Worst case, k is also n, right?
Yeah.
So it means for each element, we are trying to traverse I minus k times, right? It means k times. For each element, we are trying to back traverse k times, right?
Hmm.
So if there are n elements, for each element k times, so which is, isn't it n into k?
Okay.
If it is not n into k, what do you think? What is in your mind? Okay, so what is the space complexity here? At max you have n stacks, right? Yes or no? At max you have only n stacks, na? Yes or no, Ajay?
Yeah.
So
Yes, Renu.
it is big O of n. I'm thinking it should not be n into k. N into k is the optimistic result. What is it?
But for each element, we'll backtrack all other elements also, right? So n into nk, is it
Correct,
like
correct,
that?
correct, correct, correct. Yeah, that's correct. So yeah, what Aindevi point, oh sorry, what Maithili pointed, it is correct. So if you see, when you are at 5, right, you move on to 3 and 4, and for 3 you move on to 2 and 1, and for 2 you move on to 1 0, and for 1 you move on to 0. Now when you move on to 4, again you move on to 3 2, and again you are trying to solve 3, right? Again you are trying to solve 3 2 1 and 1 0, and here also 1 0. If you closely see, once you solve this problem, again you are trying to apply the same concept, right? So again you are trying to apply the same concept. Is it is it is it k to the power n into k or n into n into k? We need to see. Let me put some time. I'm thinking it should be k to the power n into k. Why? Because, do you understand the complexity here, Ajay? So what are we doing? So
I can see that, yeah.
we are trying to backtrack again. So you are already did here, right? So if you solve the same problem only once, then it is n into k, but you are trying to solve it again and again, right? So definitely it is going to be sum to the power of n into k. So how this this can be k, I am guessing, because you are trying to sub branch into k. For each I at max can be sub branched to k, so that it is k to the power n into k. The space complexity is linear. So how do you optimize it? How do you optimize it? So we should not solve the same problem again and again, right? Yes or no? This problem is already solved and we are trying to solve again, right? Yes or no?
Yes.
So these things should not be solved again and again, so that we need to optimize it. How do you optimize it? So now how do you identify the subproblem here?
We can store the solves the problem in a array.
Yeah, so what
For
is
that
the state
particular
of that
index.
array? What is the state of the array? How do you identify the subproblem here? Based on index only, right? Yes or no?
Yeah, based on index.
So that you will be coming up with DP array, which is of type, which is of length n. That's it. So now what we do, let me solve it. So what I'm going to do, I'm going to take new integer array of length nums dot length. Okay, so what we do, we will just, this is going to be n into k, because we don't solve the same problem again and again. So this is going to be n into k. So now we will check if dp of index is not solved, then you just return dp of index. Otherwise you will just solve it. So just make sure that you will update that to dp of index. Then here also you will pass dp. Is this clear, buddy? Maithili, Ajay? Maithili? Yeah.
So you need to update the solve signature also.
Okay. And now how this is linked to dq, right? Then that we will reveal now.
Yes.
What's happening? Time limit exceeded. K is too much. Okay. So K is too much. So that n into K is giving time limit exception. Okay. Uh, are we doing any mistake? No mistake at all. K is too much. That's why n into K giving time limit exception. Because what is the n value and k value ranging from 10 to the power 5, so definitely this will give time limit exception. If we convert into tabulation, would that work? Okay, so if you want to convert this into tabulation, how do you want to do it? Tabulation is what? It's a bottom up, right? Isn't it? So memoization we did, right? It's a memoization. It is giving time limit exception. So let me try to convert into tabulation. So tabulation means this is top down, right? So it means you are starting from last index and you are moving on to the bottom index, and you are trying to solve you are starting the problem from top and solving it, right? It doesn't matter even if you start from 0th index also, the definition won't change. But if you closely see, index 5 will be derived at last. So that's what recursive solution talks about. If you want to convert this into tabulation, so what is our job? Whatever base case you have written, right? So that is going to be your bottom up solution. So in this case, if you closely see, this is what I am doing. Let's say this is my DP array, integer array dp. So this is my dp array. So here the base case is index equals 0, right? It means when index is 0, you are returning nums of index. It means nums of 0. So whatever base case you are returning on recursive code, so which is going to be your first solution, so the base solution. In a bottom up approach, you must and should derive the base solution. Okay, so once you get the base solution, now it's time for you to solve the next sub problems. So how can you do that? Same logic. So whatever logic you keep it here, this is the logic, right? But if you closely see, earlier this index is coming through call, but now what we do, I'll keep this same, I'll copy the same logic. But if you closely see, earlier this index is coming through call. So now what we do, so for that we will return earlier what will happen, you are starting from -5, you are starting from last index, and you keep on recursively doing that. Now what I will do, I will just make sure that I will start from here. So from index starting from 1 and index less than nums dot length and index plus plus. So this is my recursive. Earlier it went through recursion, it was solved through recursion. So now I am just doing through iterative approach. So if you closely see, this is what I did. So you keep on getting max. This is the max you got, right? So once you get the max, now it's time for you to solve it. If you closely see, right, how do you want to define it? So this is my dp of index, so this is my current index, so so you can simply write, this is the logic you return, right? So max plus nums of index. Is this clear, buddy? Same logic I just copy pasted here, and I just try to solve it. Is this clear? Okay, here solve. Okay, if you closely see this solve, right, this solve is talking about what? This solve is talking about what? Bottom problems, right? Yes or no? Bottom problems, no? So this solve is the recursive call, right? Earlier we don't know. It means if you closely see, to reach index 1, I can reach from index 0. so that I can reach from index 0. So if I reach from index 0, so what is the value I am getting? Is this clear, buddy? So it means index 0 means it is start. Is it complicated? Let me run it. Actually, I didn't solve it before. If I solve it, I could have been explained better. Okay, so let me try to see how it works. Solve. Yeah, it worked. Actually, did you understand? So I just converted previous code into tabulation. So in previous code, if you closely see in recursive code, when index is 0, we are just taking the nums of 0. We are just returning nums of 0 value. So that dp of 0 means nums of 0. I am starting from index 1. Index 1 can be reached to index 0, right? So it means start becomes index 0, and index 0, to reach index 0, what is the maximum value you could gain? So which is already solved, so you just take that and you keep on update the max. Now current index is whatever max you obtain from the previous indexes, and just take that max plus current index, so which is going to be current max, so which can be useful for future updates. So at last you will have dp of length minus 1. This is what we did, right? Where is it? I just converted this recursive code into tabulation. If you closely see, this is my recursive code, right? So if you closely see in recursive code, what I did, and when index 0, I'm just returning nums of 0 value, so which is my base case. Once you have a base case, and if you see from a given index onwards, you are trying to backtrack 4 indexes, k indexes, and trying to solve every k. But if you closely see, earlier we did top down, so that we don't know the result, so that we solved it. Now we are doing bottom up, right? It means when you are at index 1, you have already solved index 0 value. That's why whatever backtrack indexes you are doing, right, which are already been solved, so just take that value. So what is the max value you could get? Then you just get the max, and current index value is good, whatever max you get plus current index, so which is going to be dp of index. At last index you will have the optimistic result, you will just return it. Maithili, is that clear, or is it like Maithili, is it clear?
Yeah, like, but the tabulation, I have to, I think, I revisit. I didn't really understand the benefit actually.
Again, it is also time limit exceeded. I think it is for both. Is there any optimization we can do? Okay. Both are time limit exceeded because k is higher, but tabulation was given for 90k. Is there optimization I can do here? I definitely look for previous 3. Yeah, so this is where I need dq, buddy. So let's move on. So we have, it is going n into k. Now let's try to optimize it with n. Okay, so let's try to optimize it. Maybe, I don't know why it is not working. Maybe I did any mistake. I don't see I did a mistake. Let's see. Okay, so now one thing for sure, what you need to understand here is, if I want to reach here, right? For example, let's pick up this index. Okay, let's pick up this index. Okay, so let's pick up this index. So I'm at index 3. If I want to reach index 3, now what is happening here is, right now what is happening, I am at index 3, I am looking for previous two indexes. What is the max value I could get to reach either of these indexes? I pick up that max and I am adding to this index, right? What is happening, from a current index I am traversing to previous, from current index I am traversing to previous index minus k indexes, so that it is somewhat n into k sub problem, which is becoming n into k, but I want to avoid that. What is the common thing you should understand here is, if I want to add this value, I don't want to, so if you closely see, this is what it is, right? So initially it is 1, so this is how my db array looks like, right? So initially this is 1, and to reach this index, so from here you will reach, so it is going to be 0. To reach this index, either you can reach from here or reach from here. So if I reach from here, it becomes minus 1. If I reach from here, it becomes minus 2. So at hope you are able to follow me, right? If you closely see, if I reach from here to here, it becomes minus 2, right? So this value is 0. So, or I can directly reach from here. So if I directly reach from here, which is going to be minus 1. Correct, nobody? Because you can take 2 jumps, right? Yes or no? So it means this is the value, right? This is the value. I can reach from previous 2 steps. So to reach from previous 2 steps, you know which step is giving maximum value. So this step is giving maximum value. If I append this value to this will become minus 1 comma minus 2, so which is going to be minus 1. Now when I come here, if you closely see, where is this? So when I come here, I can reach from previous 2 steps. So for previous 2 steps, you already know the maximum value. So this is the maximum value, so that if I reach from here, I could get maximum steps, so that 0 plus 4, so which is going to be 4. Okay, so here I got 4. Now when I am here, so I can reach from these 2 steps, right? So these two, sorry, I can reach from these 2 things. So for these 2, you already solved the problem. So it means somehow you find out this is maximum. As this is maximum, so you can directly pick, add this one, so that 4 minus 7, so which is going to be minus 3. Okay, so this is minus 3. Now when you come here, what is happening here? So this is what we are doing, right? So this one you can reach from previous 2 steps. I feel like this is maximum, so that I will add this max value to this, then I will get 7. So 7 is the answer, right? Now what is the mistake we are doing here? The mistake we are doing is, for a given index, okay, so this is the given index, I am looking for previous k values, and out of previous k results, which is giving maximum result, I am taking that maximum result, adding to the current value, and this is going to be my output, right? Till now it is clear, na? Everyone please, Maithili and Ajay.
Yes, sure.
So what is happening? Maithili, is that clear till now?
Yeah, I was unable to unmute. Yeah, clear.
Clear, okay. Right. Now what is happening here is, we are trying to compare with previous all the k values. If the k is really large, right, so which is resulting into n into k, so which is getting into time limit exceeded. Now what we can do, one thing, with respect to index 5, what are the valid indexes, buddy? With respect to index 5, what are the valid indexes? These 2 are the valid
Index 3
indexes,
and
right?
4. Yeah.
These 2 are valid indexes. Out of these 2 valid indexes, which is the valid value I need to consider for index 5?
Index 3.
This value, right? Why? Because it is maximum. Now if I am at index 4, with respect to index 4, what are the valid indexes? Index 2 and index 3, right? Index 2 and index 3. Now index 2 and index 3. So now if you closely see, what is the valid value I need to consider?
4.
Index 3 value, it is 4, right? Let's say k equal 4. I am at index 4. These 4 are valid values, right? But valid value I need to consider is 4, right? but I'm traversing to remaining 3 also. That is what causing the problem, correct nobody? Let's say k equal
Yes.
4, I am at index 4, so these 4 indexes are valid. I am looking up all the 4 values, but I just need to look at this, so that if I am able to consider this one, so that I can eliminate this. So how do you make sure that you can eliminate these values, right? How do you make sure that you can eliminate these values? That is where we will go with the concept of DQ. So what I will do, so let's move on. So this is what I am trying to do. What I will do, I will make sure that I will have a max DQ. Okay, so I will make sure that I will have a max DQ. It means in a DQ, the first element is always going to be maximum value. And I need to know every state, right? I need to know every state of a index, so that I am going to also consider DP array, the DP array of size 0, 1, 2, 3, 4, 5. And the first index value is always be 1, so that for sure it is 1, because DP of 0 is 1, so that which we already solved in tabulation, so we got 1. Now it's time for us, so first I start from 0th index. So when I start from 0th index, so in the DQ also I will definitely have 0th index. I will maintain index. Why? Because I need to eliminate wrong result. I need to eliminate wrong indexes, so that in the DQ I will only maintain indexes. So first I have index 0, so index 0 having value 1. Okay, so in the DP array I will also store the first value as 1. Now when I am moving on to next index, minus 1, right? So if you closely see in the DQ I have a index 0, it means from index 1 I can reach, means this one is valid. But what I will do, I will blindly take, so what I said, in a max DQ I always make sure that the first element is always going to be the maximum. So it means when you are at a given index, if the whatever first element present in DQ, right, if it is valid, then that is going to be the maximum. So that I am at index 1, in the DQ I have index 0, it means this is the maximum. So I can blindly take that value. Okay, fine. So I will so in the DQ what I have index 0. Now so in the index 0 I have value 1, so I will blindly take that value 1, append to this, so 1 minus 1, which is 0, so 0 will be added to the DP array, and I'll add current index to here. Why? Because if you closely see, whatever value you are appending, right, which is smaller, so at index 1 the value is smaller, at index 0 the value is larger, right? So because if you closely see, I am adding only indexes here. At index 0 the value is larger, at index 1 the value is smaller. That's why you don't delete it. So what is my max DQ property? The first element is always going to be maximum. That's it. Now let's move on. This is where you will understand. Now I am moving on to index 2. At index 2, so so at index 2 can be reached from previous 2 indexes. So if you see in the DQ the first element is 0, so which is valid. As it is valid, so the first element is always be maximum, so that you can blindly take that. So it means at 0 you have value 1, add 1 minus 2, which is going to be minus 1. So minus 1 is added here. Now it is minus 1. As it is smaller value, we will just append here. Okay, index 2 is appended here. Now let's move on. Now I am at index 3. Now let's closely understand. At index 3, the previous 2 indexes are this one, right? So these are the previous 2 indexes. Now if you closely see, you are having 0th index as a first element in the DQ, so which is invalid, because this is invalid, it cannot be reachable to index 0. So what is our job? Remove that. Once you delete it, if you closely see here, now next greater element compared to next 2 elements, right? If you closely see, the next greater element compared to next 2 element is 0, which is already at first position. So at index 1 you have value 0. Take this 0 and add it to this. So 0 plus this value 4, which is going to be 4. Now this is where the tricky works. Now closely understand, at index 3 you have value 4, right? But at index 1 and 2 you have smallest values. Delete it from the DQ. That's it. So when the current value is higher, you can blindly make sure that you can delete it, because this value is going to be the optimal for future solutions. Is that clear, buddy? This point is more critical. Is that clear, Maithili? Ajay?
Yeah.
Ajay, is that clear?
Basically, whatever the new element is coming,
Yeah.
if it is smaller than existing ones,
You can keep it.
then we do not.
Yeah,
Then
why?
keep it.
Because
Yeah,
that the smaller can be larger for future elements, because the first
correct.
element can be out of the window, right? So
Yes.
now, correct now?
Yes. So basically, the property that we need to maintain for this DQ is it should be in a
Max.
non-decreasing order, and the first element should be highest value.
Yes, yes, yes.
Got it.
That's what, right? That's where you can eliminate the time complexity. Now I'm at index 4. Now closely see, index 4 can be visited from previous two indexes, right? So previous two indexes. If you closely see, I have eliminated the DQ. So this value is not at all required, because this is the highest value, right? Which is already present in DQ. So now in DQ you have index 3. So index 3 value is 4. Add 4 to this. So which is going to be minus 3. Perfect. So you got minus 3. So as it is minus 3, it is smallest value, add that index. Fine. Now you move on to next index, which is 3. Now at index 3, sorry, next index is 5. At index 3 you have value 3 plus, so first element is index 3. At index 3 you have value 4. So 3 plus 4, which is 7. So that is your answer. So just return the last value. Is that clear, Ajay, Maithili? If it is clear, what is the time complexity? What is the time complexity, Maithili?
I think each element we will
Mm.
iterate once or nk times, right?
Is
Max,
it NK?
maybe to identify maximum.
No, 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 no. The more importantly, let me reconstruct it. So can you think one more time? So when I am reconstructing how I am doing, just think about it. I'll go
Okay.
very quickly. Closely understand. So it's not same as the logic which we did, but that will help. So initially dp of 0 is 1. Now I'm moving on to, so it means in the dq I have 0. The max dq, I make sure that it always be having maximum value with respect to current window. So when I am at index 1, I will blindly take the first value from the dq. First I will check whatever first value present in dq is in under valid window or not. Yes, it is valid window. I take that first value, which is 1. So 1 minus 1, which is 0. So as the current value is smaller than previous values, I will just add the current value index. Fine. Now when I'm moving on to here, I'm blindly taking, first I will check this is valid or not. If it is valid, I will blindly take the value from the dp. So which is 1, 1 minus 1, minus 2. Minus 1. 1 minus 2 is minus 1. So which is smaller than previous value, so which is 0. So that I can just add this.
Shrinu, just for the sake of easy understanding, can we keep the maximum value in that DQ instead of index? I know while writing the code, we'll iterate with index only, but
Because
can
we
we keep
need to
the
know.
yeah
Yeah. Okay, let me do that.
yeah
Let me
yeah
do that. So you are at 1, right? So in the DQ, you have index value as 1, it is at index 0. Correct? First is 0, right? First is 0, no? You blindly add to DQ. Value as 1, it is at index 0. Now you are at closely understand, am I doing n minus k iteration? That is what we are iterating, right? That is what we are avoiding, right? So what we are trying to do, when I am at index 1, I will blindly take the first value from the DQ, because with respect to current window, if the first value is valid, that is going to be the maximum. That's how I am constructing the DQ. So the first value is 1. Okay, it is at index 0 with respect to index 1, which is valid. So that I will add 1 to this minus 1, which is going to be 0. Now if you closely see, next value is 0, which is at index 1. So I don't delete it, because the next value is smaller than the previous value, so that I don't delete it. Now I am going on to index 2. Now you see, when I'm going on to index 2, I will blindly see, okay, whatever first value is present in DQ, it is at index 0, which is in current window, because k equal to, right, so which is in current window. I will blindly take that value, add it to minus 2. So once I add it to minus 2, it becomes minus 1. Now which is smaller than previous value, so that I will just add minus 1, which is at index 2. Now let's move on to next index. So I am at index 3. Now closely see, I am at index 3. But whatever first index present in DQ, which is invalid. Why? Because it is at index 0, right? Index 3 can reach from previous two indexes 1 comma 2, but it cannot reach from 0th index. So what I will do, I will delete it. Once I delete it, I don't do any k iterations. I will take the next first value, so next top value, so which is 0, right? So this is 0. It is at index 1, so that I take that 0, add to this 4, so this will become 4. Now if you closely see, current value is 4, which is at index 3. Current value is greater than previous value, so that I will delete it. So that I don't need to worry about these values, because this is going to be the optimistic value for the future windows. Is that clear, buddy? For the future windows, correct? Now let's move on to the next index 4. So I'm at index 4. Okay, so I'm at index 4. Fine. When I'm at index 4, so let's see, index 3 is valid. Yes, it is valid because it is reachable, and you already have a max value as 4. Add 4 to this, it becomes minus 3. Okay, so minus 3 here. It means at minus 3 is the value at index 4. Now I am at index 5. So when I'm at index 5, what I'm doing, I'm not traversing a k minus. I'm blindly checking. Okay, first value is 3. Okay, is it valid? Yes, it is valid. As it is valid, I will take that value. So what is the value I have? 4. So add to this. So which is going to be 4 plus 3, which is going to be 7. Right? So now what I am doing, am I traversing n minus k times for each element? No, right? No, right? So what I am doing, I am constructing a max DQ in such a way that it always hold a max value, and I will say whatever max value which is holding, is it in valid index or not? If it is valid index, I will take it. Otherwise, I will remove it and move on to the next value. And it's a step-by-step construction, right? And each element can be visited at max how many times?
Only once.
One is through add, other is to remove, right?
Yeah, but that operation will take constant time,
Constant
right?
time.
Because
So it is going to be 2n, right? So in worst case, every element can be visited twice. So it is going to be
Correct.
2n, right? Maitri, is it clear? Or okay, so it is 2n.
Yeah,
And
clear.
so space complexity is what?
Just the DP array order of n.
Okay. Okay, so that's where the DQ is helping us. Okay, so let me add this guy also. Okay, so what is our job now? DQ of integers. This is my max DQ, and new linked list. So what is our job? If you closely see, this is what we are doing, right? Of course, you can blindly add first index to the DQ, max DQ dot add of index 0. You can start from 1. Of course, you can start from 0 also, it will work. So what is our job? So first of all, DP of current index is going to be DP of max DQ dot, what is it, get first, right? So get first, it will return the index. So it is already, you will get an index from the DQ and value from the DP. So you will just append this. Okay, but this is what we are trying to do. But what we are also trying to do, so whenever you are getting this first index, right, you will check is it valid or not. So how do you know that? When do you delete it? If you closely see, this my index, whatever value you have, so this is, if it is less than index minus k, that's it, right? So if you are at index 2, if you are at index 3, 3 minus 2 is 1, and if you are in the DQ, if you have 0th index, you can simply remove it. So max DQ dot remove first. Okay, then if that is not the case, so you will have a good value in the DQ, so you will just take and append it. Now what is our job? Now you are trying to eliminate next element. So how do you eliminate? So if while my while whatever value you have, right? So if my dp of index, if my dp of index is greater than or equal to if it is greater than or equal to, in the dq you have a last value, right? So dp of get last. Okay, so we are trying to delete it, right? So simply you will just max dq dot remove last. Is this clear, buddy? We are deleting the older smallest elements, right? Is this clear, Ajay?
Yes, Srinu. Yeah.
So once it is clear, what we do at last, max dq dot add of current index.
Current index.
That's it. So it's a very simple code, but the analogy is very complex to understand.
I mean, the concept is same as the sliding window maximum problem that we had solved
Yeah.
using taking DQ. Yeah.
Yeah. So what is happening? We will see here dq is not empty, and we will have max dq is not empty. Somewhere went wrong. Let's see what it
Shouldn't
is.
first we need to delete, right? Before we insert.
That's what we are doing. If the current index value is greater than or equal to get last, then we will delete it. Once we delete it, we are adding to the DQ. Less than I minus k, is that correct? 3 minus 2, which is, yeah, so 3 for 3, 1 and 2 are valid, so 3 minus 2, yeah, this is fine. Where is the mistake we are doing? Yeah, so where is the mistake we are doing? Yeah, this is, yeah, where is the mistake we are doing? Tell me, buddy. I would say line number 14.
DP of index.
It should be current index, right? Nums of index from dp of.
Oh, right. Yeah. From the nums, we should get that. Yeah, not from the DP.
That's a problem we get through copy paste. Yeah, man. This was crazy. I thought I could solve through the dynamic programming, buddy. But
I mean, that one we can solve, but thing is with DQ we can further optimize it.
but it
For the
is
search and
going
insertion,
time
it's gonna be
limit
constant.
exceeded, right?
Correct.
Yeah, how can you make sure that it can be time limit exceeded? So, okay, so as we can't discuss other problem, let's fix
No,
this.
the time limit exit will definitely happen because we have to go by n into cross n cross k times.
Can't we do this? Can't we do this with? Yeah, why I am doing n minus k iterations? That's the problem, right? Let me
Yeah.
fix that. So I think the same concept we can apply here. So let me. Where is this guy? This guy, right? Okay, I understood the mistake. This one, right? So what are we doing? We blindly focusing, we blindly move on to the previous k problems, and we are making it as n into k. So what can we do? uh, any improvement can be done here. If I could able to maintain previous index is the maximum, then I can solve it in YAM. But previous is maximum, how do I know that? Okay, Yeah, previous
Correct.
is
That's
all
the challenge becomes
previous
here because of the key issues. Huh?
because previous is always be maximum, right? In this case, if I am at 2, 1 is the maximum, right? But yeah, that can be reached from 0 also. 0 could be more
Yeah.
maximum.
0 could be max, right? Yeah.
Is there any solutions given? Decreasing Q, monotonic Q, all are Qs only, bro. Brute force dynamic. Okay, this is what we did, I guess. Dynamic. Okay, it won't work, but it is dynamic. Yeah, he also did the same, buddy. He also did the same. K into M. It won't work. Okay, this is optimized DP. What it did? N log K. Okay, set T is using. Yeah. Good, 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 good.
It is deleting actually, yeah. Wants to find NT max.
Uh, this guy is using set, buddy. You know, what it did, the problem is we are using array, right? As we are using array same thing. Set, you know, right? We already solved with the tree map, right? Then we went to DQ. I think this is DQ. Yeah, that is log n, this is n. 5 solutions. Okay, whatever we written, that is also correct. But it won't run because of the time limit exceeded, but which is correct. So there is log n solution, right? You can go with the tree map and try to get the last entry. It always be maximum value, right? You can just append it. Right. Do you understand what I said?
Understood, Shinu. Like the previous problem that we solved yesterday, we used tree map to get the latest.
Yeah,
So
there you will use index, tree map, value comma index. Okay, same problem, but it's a different. Why we struggle too much? We went into DP and struggled. Okay. Actually, by reading the problem, I could easily solve it. I thought I could easily solve it, but it was somewhat critical. Am I making you confusion or how is it, Ajay? Is it clear?
I mean, if as I had practiced the earlier problem, so I find it easy to connect. But if I don't practice, then it would definitely hard to connect this back and forth. Yeah. For example, this max DQ thing, right? That index part. While writing code, I understand we deal with the index only, but while explaining, if we put the actual value, it makes the understanding clear.
Yeah.
Yeah.
Recursion is good, right? Recursion code again, you didn't understand.
Yeah. Like when we just converted quickly, yeah.
Recursion. Even I also didn't write earlier now, bro. So I just been through that diagram and just converted it.
Converted it, huh? Got it.
It's still recording.
Actually, the DQ problems are kind of top of the mind because we are solving active in the last couple of days. Recursive is kind of fading away slightly. Need more practice on that.
Yeah. Today we discussed DP, lot of things. Okay, buddy. So please practice.
Yeah.
Probably tomorrow we will come up with good problems.
Did you change the order of the problems? Because yesterday I think it was something different.
Yeah. Yesterday this is top. I think this is top and this is bottom. I thought it is medium problem. Let's discuss this medium. It was hard problem.
It's medium one only, I think.
This was hard, I guess. Yeah,
Oh, this was hard, yeah.
So I thought it is medium problem. So let's solve this. But this looks like hard problem. What people saying?
This is a medium problem only, but the thing is, we try to solve it with different approaches, right? That got lengthy. If you just go by the DQ approach, then it's a medium problem.
Yeah, it's a medium problem.
Yeah.
Okay, buddy. See you tomorrow.
Yeah.